Somewhere in the Netherlands, there are two steel arms. Each one is almost as long as the Eiffel Tower, laid flat on its side. Most days, they sit open, empty, waiting. But when the sea rises high enough, something remarkable happens. These two arms, each one heavier than an aircraft carrier, begin to move on their own. No human presses a button. A computer decides. A computer commands. A computer closes the largest moving structure ever built by human hands. And it does this to stop something that already happened once and killed nearly 2,000 people in a single night. To understand why this machine exists, you have to go back to one night in 1953. A storm surge slammed into the Dutch coast. The dikes gave way in more than 500 places. Seawater didn't just flood the land, it erased entire villages in hours. By morning, close to 1,800 people were dead. 70,000 more had lost their homes. The Netherlands is a country where a huge portion of the land sits below sea level. It survives because of walls holding back an ocean that never stops pushing back. After 1953, the Dutch government made a decision. These could never be allowed to happen again. So they began the largest flood defense project in human history. They called it the Delta Works. 13 massive structures built to seal off the entire southwestern coastline. But one gap in that coastline refused to be sealed the same way as all the others. The original plan for the Delta Works was simple, at least on paper. Raise the dikes, close the gaps, build fixed, solid barriers everywhere the sea could get in. The same design used successfully across the rest of the project. That plan worked almost everywhere, except here, at the mouth of the Nieuwe Waterweg, the waterway leading straight into the port of Rotterdam. At the time, Rotterdam was the busiest port on Earth. You cannot build a solid dam across the entrance to the busiest port on Earth. A fixed barrier, like the ones used elsewhere in the Delta Works, would permanently block one of the most important shipping routes in the world. Engineers first assumed that simply raising the surrounding dikes even higher would be enough. It wasn't. The numbers came back, and the dikes required to guarantee safety for the 1.5 million people living around Rotterdam would need to be built impossibly tall, disruptive, expensive, and still not fully reliable against the worst-case surge. Every standard solution the Dutch had already used, successfully, elsewhere, failed here. So the government did something unusual. They opened a nationwide design competition and asked engineers to solve a problem nobody had solved before. Build something that could seal a 360-meter wide shipping channel completely, and then vanish, on command, whenever it wasn't needed. The challenge came down to two requirements that seemed to contradict each other. First, the barrier had to be enormous, strong enough to withstand a storm surge powerful enough to have killed thousands of people just decades earlier. Second, it had to be invisible, completely out of the way the other 99% of the time, so the port could keep functioning normally. Most barrier designs are permanent, fixed. This one couldn't be. It also couldn't rely on split-second human judgment. A storm surge doesn't wait for a meeting. If the barrier was going to close in time, every single time, the decision to close it would have to happen faster and more reliably than any person could manage under pressure. So, the real engineering challenge wasn't just build something huge. It was build something huge, make it disappear, and make it decide for itself when to act. The winning design called for two colossal floating gates, one built on each bank of the waterway. Each gate, 210 meters long, 22 meters high, 15 meters deep. Built dry, on land, then floated out like enormous hollow ships. Each one anchored to the shore by a ball joint 10 meters across, the largest ball joints ever constructed, allowing the entire structure to swing like a door on a hinge the size of a building. Under normal conditions, both gates sit tucked away in dry docks. A 360-meter gap stays open. Ships pass through exactly as they always have. But the real solution wasn't just the gates, it was the decision-making system behind them. A computer program monitoring weather and sea level data around the clock calculates the risk continuously. When a storm surge above 3 meters is predicted for Rotterdam, the system acts on its own. 4 hours before closure, ships are warned. 2 hours before, all traffic stops. Then the dry docks flood. The gates begin to float. Two massive devices called locomobiles push each arm outward, swinging them toward each other across the water like two enormous doors closing by themselves. Once they meet in the middle, the hollow gates fill with water and sink to the riverbed, sealing the gap completely, capable of resisting a force equivalent to hundreds of thousands of tons pressing against it. Then, once the storm passes, the entire process reverses. The gates empty, rise, swing open, and disappear back into their dry docks, ready to vanish again. Here's something unusual about this machine. There's no single celebrated architect behind it. No one engineer's name attached to the design, the way a famous bridge or tower often carries one person's legacy. The winning design came from a consortium, a group of Dutch construction companies working together, known as BMK. It was one of the first major infrastructure projects where the same companies building the structure were also responsible for designing it from the ground up, an approach that was still unusual at the time. Credit for the Maeslantkering isn't claimed by one visionary. It's shared across the engineers, welders, computer programmers, and construction crews who spent 6 years, from 1991 to 1997, turning a nationwide competition entry into 210-meter steel reality. People who grew up on this coastline, in towns that remembered 1953 directly, worked on a structure meant to make sure their own children would never have to live through the same night their parents did. On May 10, 1997, after 6 years of construction, the barrier was officially opened. For a full decade afterward, it was tested every year, and never once triggered by an actual storm. Then, on the night of November 8, 2007, the predictions crossed the threshold. For the first time, the barrier closed for real, not a drill. The storm passed. Rotterdam stayed dry. Today, the Maeslantkering stands as one of the largest moving structures ever built by humans, and a working answer to a question every coastal city on Earth is now asking with increasing urgency as sea levels continue to rise. Engineers estimate the barrier will need to close roughly once every 10 years under current conditions. In 50 years, that number is expected to fall to once every 5. The ocean isn't backing down, and this machine isn't a monument to a problem that was solved once. It's an ongoing negotiation with the sea, one that never actually ends. The most impressive engineering isn't always the structure you can see. Sometimes it's the machine built specifically to disappear, to stay invisible for years, so that in the one moment it truly matters, it can hold back an ocean. The Maeslantkering doesn't look like a monument. Most days, it doesn't look like anything at all. And that emptiness, that quiet, waiting gap in the coastline, might be the most impressive engineering decision in the entire story. It's built to do nothing almost forever, until the one night it has to do everything.